This is a lesson on the law of sines. The law of sines is used for oblique triangles. An oblique triangle is a triangle that does not have any right angles. So a triangle without any right angles might look something like this. And from geometry, you're used to labeling your angles and your sides. So in this case, I'm going to label all the angles with uppercase letters. So if this is angle A, I'll call this angle B, and this angle C. The side opposite angle A, I will label lowercase side A. The side opposite angle B, I'm going to call lowercase b, and the side opposite angle C, I'm going to call side C. The law of sines is a proportion. There's a relationship between all the sides and angles. So this proportion or ratio is going to be sine of angle A is proportional to side A, as the sine of angle B is proportional to the side B. Likewise, sine of angle C and side C. The cases that use law of sines are going to be when you have two angles and a side that's not between them, or when you have two angles and the side that is between them, or when you have two sides and the angle that's not between those two sides. Those are the only three cases that you use law of sines. And you need to know which cases, because when we use law of cosines, there are going to be two different cases. Notice that this case has two angles, and this case has two angles. If it has two angles, you can easily find the third angle. The third case only has one angle given, so it's not as easy to find the other angle. This is called the ambiguous case. The ambiguous case happens because there may be no triangles possible, maybe one triangle, or maybe two triangles. This is the case that most people have difficulty with at first, and I'll go through each of these cases with examples. The first case I'm going to look at is example 1, where I'm given angle B is 29 degrees, angle C is 102 degrees, and side B is 28 feet. So let's go ahead and draw this and see what it looks like. If I label my angle B is 29 degrees, C is 102 degrees, and side B is 28 feet, then I'm going to call this A, side A, that's B, that's C, and this is going to be side C. And I'm going to set up my proportion. So I know the sine of angle A over side A is equal to the sine of 29 degrees over 28, and the sine of 102 degrees over side C. You notice that I do have both of these terms, so I can get a number there. I do not have any terms for A, but I do have the angle for C. So I'm going to go ahead and cross multiply, and I'm going to ignore this part here. And when I cross multiply, I get C times the sine of 129, or pardon me, C times the sine of 29 degrees equals 28 times the sine of 102 degrees. I want to find C, so I'm going to divide by the sine of 29 degrees. So when I put this in my calculator, I get C is equal to 56.49 feet. If I put 56.49 feet there, now I want to find angle A and side A. Well, I can find angle A because I'm given angle B and angle C, and there's got to be 180 degrees in every triangle. So I'm going to say sine of angle A, well, I don't need sine of angle A, I need angle A is going to equal 180 degrees minus 29 degrees minus 102 degrees. So angle A is going to equal 49 degrees. Now I've got everything but side A. So now I'm going to go ahead and ignore this last term here, and I'm going to put 49 degrees in for angle A, and I'm going to have sine of 49 degrees over A is equal to sine of 29 degrees over 28. And when I cross multiply, I get A is going to equal 43.59 feet. And I've solved the whole triangle. Now let's look at example 2. Example 2, I'm given two angles again and a side. So this first case I was given these two angles and the side that's not between them. So this is going to be angle, side. And when I draw this and label everything I know, I have 43 degrees for angle A, 98 degrees for angle B, side C is 22 feet. So I don't have angle C, I don't have side A, and I don't have side B. So now I have the two angles, but the side I have is between the two angles. So this case is going to be angle, side, angle. I'm going to set up my proportion like I did before. So I have sine of 43 degrees over A equals sine of 98 degrees over B equals sine of angle C over 22. Since I have these two angles, I can easily find angle C. So angle C is going to equal 180 degrees minus 43 degrees minus 98 degrees. So angle C ends up being 39 degrees. Let me go ahead and replace this with 39 degrees. Now I can take any side to find, I can find side B by cross multiplying this, and I can find side A by cross multiplying, ignore the one in the middle, and have 22 times the sine of 43 degrees equals A times the sine of 39 degrees. So I'm going to cross multiply. I get 22 sine of 43 degrees equals A times the sine of 39 degrees. Divide by the sine of 39 degrees. And I get A is equal to 23.84 feet. Now I want to find side B. So I don't need to use this. In fact, I don't want to use that. In case I calculated A wrong, I don't want to use that value. I know that these are correct. So I'm going to use this proportion here. So I'm going to cross multiply, and I get 22 times the sine of 98 degrees equals B times the sine of 39 degrees. Divide by the sine of 39 degrees. And I calculate B to be 34.62 feet. One thing I have not mentioned yet is when you're doing this, notice that your angles are in degrees. We're not using radians with this. So you have to make sure that your mode on your calculator is degrees, or you're going to get some really weird answers. So that's the first thing you do want to make sure you check, is that your mode is on degrees. Okay. On the back, I'll do a couple more examples, 3 more examples. Now this one here, I'm given angle A, and side B. So this is now where I do not have two angles, I only have one angle. So I'm pretty sure this is going to be side angle, but I'm going to go ahead and draw it to check. So I'm going to label A 42 degrees, Angle B I don't know. Side A is 22 inches. Side B is 12 inches. I don't know angle C, and I don't know side C. So I've got this angle, this side, and this side. So notice that the angle is not between the two sides. So the case I'm talking about is side-side angle. Now I can set up my proportions. I'm going to have sine of 42 degrees over 22 equals sine of angle B over 12 equals sine of angle C over side C. I can't use this at all. I'm going to ignore that completely. I'm going to cross multiply with these two terms here. So I'm going to have 12 times sine of 42 degrees equals 22 times the sine of angle B. Divide by 22. And I get sine of angle B is equal to 12 sine of 42 degrees over 22. When I put that in my calculator, let me find my paper where I have it done already. I'm going to get sine of angle B is going to equal 0.36498, and it keeps going. Well, that's not the angle, that's the sine of the angle. So then I have to do inverse sine. And angle B ends up measuring 21.41 degrees. So now that I have angle A and I have angle B, I can find angle C. So it's going to be 180 degrees minus angle A, which is 42 degrees, minus angle B, which is 21.41 degrees. So angle C ends up measuring 116.59 degrees. And then I come back here. So now I have all three angles. I have two sides. I want to find side C. And I would just place all the numbers back in here again. I would probably use the first term, sine of 42 degrees over 22 equals sine of 116.59 degrees over C, and I cross multiply. In this case, I'm going to get C is equal to 29.40 inches. Now on the front I had said that there might be one case, two cases, or no cases. In this particular instance, I only have one case. And I'll explain better why in a minute. But what you're going to see is if I have 42 degrees for angle A, and I calculated angle B to 21.41 degrees, it's possible, if you remember inverse trig, that angle B could be a different angle too. It could be 180 degrees minus 21.41 degrees, which is going to be about 159 degrees. But if you've got 42 degrees for angle A, you can't have 159 degrees for angle B because 42 plus 159 is larger than 180 degrees. So I know that that cannot happen. So this is going to be one triangle. Example 2, or example 4, excuse me. Once again, I'm given one side, or one angle and two sides. If I draw this out and label everything, this is 85 degrees, this is 15 inches, and this is 25 inches. So this once again is side-side angle. So I have sine of 85 degrees over 15 equals sine of angle B over 25 equals sine of angle C over side C. I'm going to ignore this again, and I'm going to cross multiply this. When I cross multiply this, I get sine of angle B is going to equal 1.66032, and it keeps going. But if you remember, we already did our graphs for sine and cosine. The domain is all real numbers, but the range, so the angle could be any number, but the range is the sine of the angle, has to be no greater than 1 and no less than -1. Since this is greater than 1 and I try to find it in my calculator, it's going to give me an error. So the range for sine is going to be from -1 to 1. So I cannot find this. This is where there's no triangle. No matter how hard I try with that information, I cannot make a triangle. My last example for this lesson, example 5. Again, I'm given one angle and two sides. I'm going to go ahead and sketch it to see what it looks like, just to make sure. I have 20.5 degrees on angle A. Side A is 12 meters, and side B is 31 meters. I don't know side C. So sine of 25 degrees over 12 equals sine of angle B over 31 equals sine of angle C over side C. Once again, ignoring this, I'm going to go ahead and cross multiply. And when I do this, I get sine of angle B is going to equal 0.9047. That number's less than 1 and greater than -1, so I can do that. I do inverse sine, and I get angle B is equal to 64.8 degrees. And I'm going to go ahead and I can calculate C by 180 minus 20.5 minus 64.8, and I get angle C is going to equal 94.7 degrees. Once again, plug the values back in, cross multiply, and I get C is going to equal 34.2 meters. So there I am solving my whole triangle. A minute ago I said we had 3 cases. No triangle, 1 triangle, 2 triangles. This is going to be an example where there are 2 triangles. To get the second triangle, since I did inverse sine and got this value, sine is also positive in the second quadrant. So there's an angle in the second quadrant that also has this sign. To get that, I'm going to go ahead and take 180 degrees and subtract 64.8. So I'm going to get angle B is going to be equal to 115.2 degrees. In example 3, I showed you how I checked to see if it worked, and it didn't. Here, I've got 20.5 degrees for angle A, 115.2 degrees for angle B, so that does give me enough left over for angle C. So then angle C is going to equal 180 degrees minus 20.5 minus 115.2, and I get angle C equals 44.3 degrees. Set up my proportions again with this information. I'm going to calculate side C to be 23.9 meters. If you're having a hard time understanding this ambiguous case, you're not the only one. But maybe I could give it to you in a visual way also. If I'm doing a graph of sine function, so I've got, and I'm used to doing radians, so if this is 90 degrees, this is 180 degrees, 270 degrees, and 360 degrees. I know the sine is going to be 0 at 0, 180 degrees, and 360 degrees. I know sine is equal to 1 at 90 degrees, and it's equal to -1 at 270 degrees. So here's my sine curve, and it keeps going. But in a triangle has 180 degrees, so I'm only looking at this information for a triangle. I don't care about any other angles. So when I said the sine of the angle was equal to 64.8 degrees, 64.8 degrees, let me grab another color. 64.8 degrees is about right here. And you can see that value would be about 0.9. If I keep going over here, there's another place where the sine of the angle is 0.9. And this angle right here would be the 115.2. So there's two places that have the same sign, and that's why it works here. There were two places on example 3, but there was no way to get 180 degrees with all three angles. This one I can get 20.5 plus 115.2 plus 44.3, and that will equal 180 degrees.